Go ahead, Jeff.
Thanks a lot, and good afternoon, everyone. My name is Jeff Houston. I'm from the Philippines. They can't hear me. Can you hear me now? I'll keep projecting until it works. Okay. You know, I'm old enough to remember the internet before V6. And that's a pretty big boast because, quite frankly, a lot of you have made an amazingly long career out of talking about V6. So, you know, it's after lunch and you need some exercise. Hands up everyone who's heard 100 V6 talks. Cool, I expected that. How about 500? Yeah, right. 500 is up there, and possibly a few of us have even sat through 1,000 of them. And the funny thing was, it's a bit like spam and security. No matter how much the security guys blather on, my mailbox is full of spam. They don't seem to be making one jot of difference to the problem. We talked and talked and talked and talked about V6 and nothing happened for years. So most of you, particularly the 1,000 people, are immune. Nothing I can say will make the slightest bit of difference because I guarantee all of you have heard this before. And so has the entire industry. You've all heard it before. Nothing I can say will make any difference at all. But what are you doing? And this is where it gets really interesting, because what you're doing this year is different. Thank God there's something different to talk about, because otherwise it'd just be more blathering. So apart from me blathering, I've actually got 3 people here in this panel who are able to tell you what they're doing. John Brzozowski from Comcast, Gaurav Madan from T-Mobile, and Paul Sub from Facebook. But before each of them talk about what they're doing, let's have a look at the result of this. You know, when we used to do these V6 talks about 10 years ago, it was always, oh, that country over there is so much better. Oh, Japan's got a brilliant V6 thing. Oh, it's all happening in China. Somewhere deep, dark in the jungles of Borneo, it's all V6 and the rest of the world isn't with it, you know, blah, blah, blah. And it was always pointing at someone else. So which country is at the top of the V6 stakeholder list? Which country has the most V6 users by head count? This one, right here, right now. The countries that are coloured a deep green are the United States, Peru, believe it or not, Peru, Portugal is doing bloody well, Germany, Belgium, and Sweden, and little bits of Malaysia. What a strange mix. But this country is at the top. This country has now got more than 1 in 5 users, and you have a lot of users in this country. You have a lot of users. And the best we can see right now is you have about 1 in 5 who, when given a V6-only URL, will follow it and retrieve it. We were doing this a year ago. Oh, so what? 5%, who cares? 2 years ago, you'd be looking around with an atomic microscope. So inside that 24 months, astonishing things have happened here in this country. Why? Who's responsible for such a change? Because it's happened without the blathering, without the talks. It's happened because operators have actually started moving this stuff around and delivering it to customers. And we can see it now. This is just one, but it happens to be one of the largest providers in this country. They service well over 20 million odd users, and 45% of that user population, well in excess of 20 million, well in excess. 45% of them respond in V6. The country levels are down there, slightly lower in the green and the orange, but look at that red and blue. Who could and who, if you will, prefers to use 6. That's amazing. So previously, when we talked about 6, there was only ever one answer from the operator community. I will do it when everyone else does it. And that was the right answer, because we're in a network. I can go and run IPv10, but I'm an idiot and I'm consigned to speak to myself. If no one else is doing it, you're wasting your time. But when everyone else is doing it, you have to do it too. So this is now very interesting that some of the largest providers in this country, and the Comcast story, you can see a comparable one with Verizon, a comparable one inside AT&T, a comparable one inside T-Mobile, are now pushing out V6 all the way to the edges. What happens if you're a content provider such as Facebook? How do you respond to that, and what do you do with your content? And that's what we're going to hear today. Because all of a sudden, when you're saying, I'm waiting for somebody else, if the somebody else isn't Comcast or AT&T or Verizon, who the hell are you waiting for? You know, exactly which provider is your trigger provider if you're seeing the major providers in this country already making massive moves towards this protocol. So this is a very interesting point at this time in this year, that all of a sudden it's no longer blather. The gears have changed, and now we're seeing inside this country a huge shift. How is the response in other countries? United Kingdom, nothing. France, puh. Germany, serious, massive deployment in 6. You look at the same graph for Deutsche Telekom, you see a similar up and to the right. So it's not just here, it's now gathering momentum. If you multiply the network by the GDP per capita of its user base, what you find is around 30 providers control around 40% of the value of the entire internet. Of those 30 providers, 6 are now making massive moves into V6. So what are you waiting for? Because my suspicion is that the folk you are waiting for have disappeared from the room. They've already gone and done something, and if you think, oh, well, I've still got a few more years, it's okay, go on and think that, but I'm not sure it's the best business plan. So with that as kind of a lead-in, what I'd like to do first is talk to John to see what the story is behind that astonishing graph. How they can get 45% of those millions of consumers running 6 in such a short time. So John, over to you.
Thank you, Jeff. Always a tough act to follow. Very, very large shoes to fill here. So, so a little bit about our work at Comcast from V6 point of view. I wanted to start this off a little bit with some visual aids for that represent kind of our growth over the past year. It's about a year almost exactly, end to end. If you look back about, say, March, say from a couple years ago, this is like 2013, you'll notice that over the past few years, our growth from a deployment point of view has done nothing but gone up to the right. You'll also take note that we've had our share of things that had to be adjusted along the way. We have some valleys that go with our peaks, but generally, everything corrects and continues to move up and to the right. Back. This is the most recent graph from care of the Internet Society in the World IP6 launch page. It certainly complements Jeff's, the prior slide, but we really wanted to highlight this because the bulk of what we had done when we had turned on V6 initially for the device that we provide to our customers, it was only really in the first batch. That was followed by a very large push to get the rest of the device that we provide to our customers updated with software to support IP6, and we turned it on by default. So throughout the period of 2014, we really enabled the vast majority of our V6 through software upgrades and configuration updates. All that hardware had already been deployed. And I share this with you to give you a little bit of background around kind of what's not important anymore. So this to us is kind of old news, right? We're getting to the point now where even though these graphs say 40%-ish, we really have 65% of our customers that have native IPv6 connectivity. Getting to the point where the penetration from this point forward will take a bit longer to kind of get us closer to 100%. I say that to you because, we're at a point now where, we have so much V6 available. The infrastructure is really so ready, and so many people within the company have spent so much time kind of making sure everything works and works well, that we're really starting to look at what's next with V6. And you'll see towards the tail end of kind of the short set of slides that I have here, kind of a synopsis of what V6 has meant to us at Comcast, to all of you over the past 10 years. And I'll use that to kind of tee up a little bit of a discussion and hopefully some interactivity from you all about, like, where do we go from here, right? Over 60% of our customers have native V6 connectivity today. We anticipate that perhaps by the end of this year, early next, that could be 80, 85%. And I think we all recognize that the last run there will probably take a little bit of time for us to kind of get that taken care of, meaning enable V6, because, frankly, we don't provide a device to every Comcast customer. Many folks, probably many people in this room, really prefer to bring your own equipment, which is perfectly fine. But we're doing a lot of work with the industry, not only internally, with the industry, to make sure that even that equipment has support for V6 and hopefully is on by default as well. Over 10% of our internet traffic is V6 today. And for some, you guys say, wow, that's pretty good. And I think from our perspective, it's okay, right? I think we really expect and want to see that number move up a lot closer to actually the penetration that we have from a V6 point of view, closer to 60%, right? They should nearly match and I think throughout this discussion you'll find there's a few nuggets of things that we're going to point out as to what we think is kind of holding that up. And we're not done, right? So we've taken V6 to 60%, talked to you a little bit about where we're going, but we're not even, that's not the end of it for us. So from our point of view, V6 is a way of life for us, right? We use it for a lot of things in the company, right? It's integral to how we manage our network, how we deliver products and service to our company, to our customers, and frankly, all of our products and services will support IPv6 only in many cases. One example that we've shared with the community over the years, probably earlier this year, and some of the other V6 conferences is our X1 platform. We'll go V6 only, no V4. And those migrations will actually start not very long from now. The same will apply to voice over our voice offering from a Comcast point of view. So from our point of view, we've really taken the past 10 years, prepared ourselves from an infrastructure point of view, leveraged each step as a building block to get ourselves ready to really, to take advantage of V6 and the benefits that it offers, to run our business, right? To continue to do the things that we need to do to kind of develop products and services that our customers want and need. But we're at the point now where V6 is so pervasive, and V4 is soon to be depleted, right? Where we're looking at the use of V6 to carry IPv4, to the point where we're saying what is next, right? So there's really kind of two fronts here. We have V6 as pervasive, and as you've seen through from Jeff's graphs, we continue to see growth, but we're now looking to kind of continue in that journey, leveraging V6 not only as a foundation for innovation, but also to continue to do the things that we need to do to kind of support the business and ultimately our customers. V4 as a service is one of those, right? V4 as a service is basically a connection to a broadband connection would be essentially V6 only, and as many of you know, the LAN inside of your home it'll be many years. I'll be gray and visiting Jeff in Brisbane while he's retired, when a V6 only LAN is a reality. So V4 on the LAN, probably will be around for quite some time, right? And that's not something that we can ignore. So V4 as a service, whether there's address sharing at the other end of it or not, is likely something that I think we're all going to see in the not distant future. But more importantly, V6 for us is really that foundation for innovation. There's a lot of things that we found over the years. They were little tidbits. We always found like these little nuggets of things that said, oh, this is useful about V6 and that's useful about V6. But now we're getting to the point where we're finding that there's a lot of interesting things that we can do with a fully V6 enabled infrastructure. taking out v4, for example, right? As the routing table grows, removing v4 has some benefits. v6 segment routing, for those of you who are tracking the work in the Spring Working Group and ITF. And v6 content delivery kind of goes hand in hand with our X1 platform, but it's not only related to that. So before I hand off to Gaurav, for us, v6 10 years ago was really mainly about more addresses, but not so much anymore, right? It's kind of old news. We do find that v6 absolutely performs better than v4. A few years ago, we shared some early results from some of our testing. We find that in many cases, v6 does outperform IPv4. And I think it's important for people to note here, as v4 kind of continues to change, that I think that's only going to increasingly become the case where v6 is outperforming v4. And truthfully, v6 is absolutely operationally more simple than v4. And frankly, folks, it's really not that hard to deploy. And from our point of view, like I said, we really do view it as a platform for innovation. And with that being said, I think I'll hand it over to Gaurav.
Thank you, John. My name is Gaurav Madan. I work for T-Mobile on the network side. It's quite interesting facts presented by John, like 60% of their customers are on IPv6. So we'll try to build on that. As you know, T-Mobile is one of the leading LTE and GSM provider in the industry, and because of our Un-carrier strategy, our customer base has increased from like 49 million from last year to 56.8 million this year. So more customers means more devices within the network. More devices means more IP addresses within the network. When I say more IP addresses, it creates more problem of, we need more public IP addresses to be available, and that, as we all know, IPv4 is a rare commodity right now. So to solve that problem, we opted for IPv6 only. So we evaluated IPv6 only approach and deployed it on our network. Now, why would we do that? The first one is the IPv4 issues that we're trying to solve, because the address space is getting depleted day by day. It's creating more sessions, and the more devices comes into the network, the more sessions it creates. Now, the second problem we faced was after the NAT64 deployment in our network, we figured out that some of the native IPv4 only application doesn't work with NAT64, because they require an interface on the device which has to be IPv4 to generate traffic, and with native IPv6 clients we can't do that. So T-Mobile started working with JPIX and NEC at that time, along with contribution from Google, and they came up with a concept of NAT464 X-Late. What that does is it moves the translation for the stateless connection over to the client operating system, and then NAT64 happens on the network itself, which is stateful translation. So that creates another avenues of how IPv6 only can be deployed within the carrier networks, and also what are the benefits you can get out of that. So we'll talk about that in other slides. Now, to support further, Google deployed Android 4.3 in October 2013 and releases the support for NAT464 X-Late. So that moves the CLAT on the devices itself, and as I mentioned earlier, the provider or PLAT towards the NAT64 environment. After that, Microsoft also came forward and releases Windows 8.1. And in September 2014, and T-Mobile took advantage of both of these and enable NAT464 support by default on all the new devices. So IPv6 only network is really scaling on our side. So the next slide will show you the graph. So this is very interesting. I don't know if whoever was present in the last NANOG in June 2014, we were at around about 27% of our subscribers were IPv6. Exactly after 1 year, you can see that it is more than 54%. So it's 100% growth, or more than 100% because it's close to 55% now, and it will keep on growing. Now, what are the prospects of IPv6 in the carrier side? So TMS now have more IPv6 users as compared to IPv4 because of NAT 464 deployments on the operating systems on the handset itself. We don't use dual stack. It has to be IPv6 only or IPv4 only. And if this trend continues, the growth that I showed in the previous slide, then I'm pretty sure in next 1 year, this number can hit 70 to 75%. And there is a example here with a diagram how NAT 464 works on the operating system on the handset and how it plays with NAT 64 on the provider network. So there are 3 scenarios. The first one is where NAT 464 really comes into play. For example, you have like applications which are IPv4 only, and they require an interface on the operating system itself to generate traffic towards V4 servers. So I don't know if anybody has a T-Mobile handset who's using Android 4.3 and later versions or Windows 8.1, you will notice if you're looking at IP address configuration on your handsets, you will have a CLAT interface which will contain like 192.0.0.4 IP address. So that's where the IPv4 traffic is generated. And if you also notice, there is also a unique global IPv6 IP address assigned to a different interface. So the handsets generates the traffic, or the application client on the handset generate the traffic on a V4 only network that is intercepted by the operating system and translates that to a V6. So, excuse me, it translates both the source IP address and the destination IP address. The source IP address is more of a unique global assigned to the handset by the DHCPv6 or GGSNs. And the destination IP addresses are more synthesized quad A records, which is the job of DNS64. Once that's done, the traffic enters, as you can see, on an IPv6 network only. Once it reaches the NAT64 platform, because this traffic is DNS synthesized, it has a prefix 64 defined in the destination. It gets intercepted, goes to the NAT64 platform, it gets converted into IPv4 now. So both the source and destinations are converted into IPv4 and the traffic goes out. The source is being used from the global IPv4 addresses pool available to T-Mobile, and the NAT64 takes care of rest of the stuff. The second is more of IPv6 to IPv4. These are for the application clients which can handle IPv6 or generate IPv6 traffic. So in an IPv6 environment, when the traffic goes out, it's again similar to I explained earlier, except there is no translation that happens on the operating system on the handset itself. So like, application is trying to access something over the internet, which is IPv4. It sends a DNS query. The DNS comes back with a DNS64 on it with a synthesized record. The traffic goes out, intercepted by NAT64 in this case because it's generating IPv6 only, and that converts it back to the V4 and goes out. If it's V6 to V6 traffic, it does not go through any kind of translations or straight out. This is what we are aiming for in the future. Now, what are the benefits we are reaping out of IPv6 only deployment? Our edge network growth no longer relies on IPv4 address space availability over the internet. This address space is already depleting. There is no need for more IP addresses there if you have IPv6 only. All client and web traffic, because some of the major applications doesn't work with IPv6 only, so this NAT 464 introduction helps in resolving this problem. We don't control the internet. We can't have application developers, we can't force them to develop IPv6 only applications. Or our web contents, which is available over the internet, contains some of the IPv4 literals or referrals that contains IPv4 addresses back into that delivers back to the client. So that's where the problem comes in. So once you have the NAT 464, you are independent of application developers. You can do whatever you want, until the application developer fixes their stuff, things will still work. So it's a better user experience. And it also creates a simplicity in ISP network because you don't need to deploy more NAT CGN environment, which is more of a carrier-grade NAT or LSN environment or infrastructure. It reduces the CapEx and OpEx cost. It's better to, it provides better visibility, it provides better monitoring, it's more simple to manage. You don't need to gather KPIs from at the different layers of the network. You just need to gather at the source, and you're good with that. So with that, I will hand over to Paul, who's represent what Facebook are doing today.
Hi, I'm Paul Saw from Facebook. We approach things from two sides. We've done IPv6 only on the internal network, but I want to talk more about why we think more of the content providers need to deploy IPv6 and how this is going to impact the eyeballs. John talks about, years ago we were sitting around and he talked about that he saw V6 as faster, and that got me thinking, is it really faster? So we started instrumenting and doing more on the desktop side, and we saw a little bit of improvement. But what's really important to look at is what we've been seeing in the mobile space. With the mobile space, it's a little bit more tricky to instrument because you have to instrument on the client, and we started to notice things on the server side. Things were faster, connections were completing much quicker. So within the last few months, we started instrumenting our Facebook and Android apps, and people have been saying, oh, well, if you just use the native network stacks, they have happy eyeballs built in, you're going to have bias. So this is where we have basically built something called Mobile Proxygen. And Mobile Proxygen is like our high-performance C++ library that does all of our network connections, handles all of our performance calculations, and we control whether we do happy eyeballs or not. So one of the things that we presented this past March at the World V6 Congress was we are basically seeing somewhere between 20 and 40% throughput improvements to the end user. We can't explain this because we don't control the mobile networks. We can only explain what we see. And we're currently embarking on A/B testing this, where we will force a large percentage of users to do V4 and then a large percentage of users to perform happy eyeballs. We believe that this will hopefully show us that the performance gains are actually still there, and they are. We're still tweaking the results. But as you see here in the United States, I can't actually name who this is, but everybody does know who it is, that on this provider on iOS, it's 40% faster. And we're talking 1 second versus 2 second type of performance gains. And we've sat down and we've what causes this? And it's because we don't have any of this V4 nonsense in the middle. We don't have carrier grade NATs. We don't have TCP optimizers, or as I like to call them, unoptimizers in the middle. And faster client interactions is going to be faster. You're basically going to end up with your users using your service more. They're going to be enjoying your service more. They're not going to get frustrated and throw their phone across the room when it's slower. I think it's the biggest thing that we should be focusing on. How do we get more V6 content out there? Right now, I don't remember the number off the top of my head, but the Alexa Top 100, I think it's 10% or less have Quad A records today. And that's pretty sad. We at Facebook believe V6 is the future, and our mission is to connect the world, and we cannot connect the world without V6. So our stance has always been more content, more content, more content. The only thing we don't support today is Quad ANS records. And that was a huge undertaking for us to get to that point where our apps will work on a V6 only network as long as your name server is dual stacked. And we'll have Quad ANS records sometime within the next few months. It's just been a human resource issue. I also want to point out that it took us about 2 years to get to where we are today. And that might seem like a long time, but today, we look at what the internet traffic looks like, versus V4 versus V6. And what I find really interesting is, we all know the internet curve where Wall Street closes, everything tapers off, everyone goes to dinner, then they get online after, then they go surf their YouTube and watch their Netflix, and everything peaks a little bit more. That's the V4 world. You have the stock market close peak, and then you have the evening peak. The V6 world, it's flat until the market closes, goes down a little bit, and then it really spikes up for V6. So why is this? It's because corporate America does not have v6 in their offices. I mean, really, that's the biggest problem. And, you know, I've done a bunch of interviews over the last couple of weeks with various people. They're trying to focus on, you know, v6 costs too much and whatever. And I really don't think it costs a lot to turn on v6 to your desktop. I'm not, you know, I don't tell people, let's turn on v6 to your printers, your phone systems, or whatever. The idea is that you want to get v6 an experience for your end users, the people in your offices, so that this graph matches the v4 graph. You might not have as much traffic, but we need to get to the point that everybody's using it, everyone's getting experience with it. And if we don't get there, we're going to be stuck. You know, we see the same thing that John sees. We see over 12% of our traffic to the internet is v6. That's actually pretty huge. You know, I remember when we launched it, it was just a tiny fraction. We've been doubling year over year, and we do things to just push more v6 to our origin. For instance, iOS, its Happy Eyeballs implementation, only about 20% of the time it will select v6. Even though v6 is faster for throughput, they choose to select based on RTT. So the data that we see is RTT is more or less equal on v6 versus v4, but throughput is higher. Why is that? I can't explain. I don't know what's in between. Again, it could be CGN, it could be TCP optimizers getting in the way. But with the previous slide, iOS is actually faster. So when our mobile proxygen takes this into account with our Happy Eyeballs implementation, and we end up serving over 80% of our requests over v6 on iOS instead of 20%. And this is something that every app developer will encounter. We hope to open source mobile proxygen so everyone can just use this, but you know, that's a problem. It's people thinking, oh, well, v6 is slower, so I'm going to make it so that my users are not going to get penalized. But what's the big deal if you like give something a 1 or 2 millisecond head start? That's not going to impact the overall experience for a user. 100 milliseconds, sure, the user's going to throw their phone across the room. But 1, 2, 5, no big deal. This is what we've been fighting with Apple for the last couple of years. So I look at it from the content side, and we need more content providers to be deploying v6. We also, you know, we're doing a pretty good job in the US with deployment. You know, they're almost at 50%. They're almost at 50%. Other carriers are in the 70s to 80s in the United States. An interesting fact is AT&T and Sprint have just started doing v6 dual stack on all their new devices. If they were just to release iOS, both of them, they turn on dual stack, it'll be a 4% rise in global usage instantly. That's pretty huge. The US will probably be 1 in 3 users will have IPv6 at that point. So I think the onus is on us to move more aggressively, and let's not run 2 networks. It's too annoying. We chose at Facebook internally to remove v4 from our network. So basically, more or less, we have v4 at our edge, and we transit everything internally over v6. Our back-end services all speak v6. The only v4 that exists on our network is in the network layer. No applications talk v4 anymore because we just don't want to manage it. You know, 32 bits of extra address space takes memory to keep track of in all of our applications. So that's all I have to say, and you know, we'll take questions now.
Thanks, Paul. Now I have a few questions for each of you, and let me say right up front, in case you watch their eyebrows head to the ceiling, I haven't told them what the questions are. So they are coming as a surprise, but that's okay, we're going to enjoy it. Gaurav, Mr. Mobile Industry. Ever since Methuselah was a really young child, in fact, since the days of Adam and Eve, the mobile industry is hidden behind NATs. The very early days of GSM, it was natted. You've lived behind private address space and one-way connectivity on mobile handsets forever. How does it feel out there in the world of public addresses? Do you feel naked? Do you feel exposed? what's it like to come out from behind a NAT?
Well, interesting question. So we have been doing like NAT 4.4 and NAT 6.4 for a long time, right? And it's always been a challenge to understand, gather KPIs, how things are going on, and if someone complains, hey, this user is not working properly, we have to figure out what the NAT address is and trying to, go through like tons of logs and then try to take captures and look at the KPIs and how the response time is, and then try to figure out what's going on. With no NAT in between, it's really amazing. I can tell you, like, the user experience, we receive very less issues on IPv6 itself. So overall user experience, has improved a lot in the last two years, I would say. And, the number of issues coming to us has reduced a lot as well. So it's been a great journey.
So it feels good to shed the gnats.
Exactly.
It feels good out there in the sunlight, doesn't
Exactly.
it? Okay, thank you. You're not off the hook.
All right.
I have one more question. I noticed Comcast is busy doing all these kinds of Wi-Fi handoffs. So now if you're a Comcast customer, you can wander around San Francisco and use the local Wi-Fi. And in fact, Wi-Fi handoff is a huge aspect of this industry right now. AT&T is doing a whole bunch of base stations, whatever. You're running 464XLAN. How do you handle Wi-Fi handoff?
I'm not from the Wi-Fi background, so I'm sorry. I can take that question and apply
I
that to
told you I
sir.
gave them no warning. Okay, John. This industry is really good at making my problems your cost. We put NATs out and put them in customer land first because it was cheaper that way. We're very, very good at externalizing our cost. So when V6 first came along, we, the industry in carriage and access, said, not our problem. If you want 6, you're going to have to tunnel. It's your problem. When are you going to make V4 the customer's problem? They have to tunnel all the way in, and you're just going to say, our service is 6, that's good enough. When do you see that point coming?
Is this on? Can you guys hear me? Yeah. So Jeff, thank you. Honestly, at this stage of the game, I think it's a forcing function, right? With the depletion of V4 finally happening, as you said earlier, for all of us who've heard, 1,000 talks or whatever, the V4 has been running out for a very long time, right? So the boy's been crying wolf for entirely too long. But I think at this stage of the game, if you were to ask John, right, finally, John Curran, he'll finally give you an answer to a question that we've wanted him to answer for years. When's it going to happen, right? For years it was, I can't say, I don't know, right? I think you get a different answer from John these days. I don't know if he's here or he'll throw something at me, but now you get that answer. And that does change the dynamic around when these things happen, which is part of the reason why when, with the update we shared with you here for V4 as a service, I think as an industry, we all need to plan for that, right? And we need to plan for it in a way where it's not, accidental support for IPv6, for V4, but we deliberately plan to make it so that it's less problematic, right? So V4 as a service is absolutely intended to be that, and frankly, I see that happening over the next year and a half, right? I mean, I think we'll start to see that appear in the not distant future. We'll run some trials of it this year, happy, and like we've always done with the community, we'll share those invites out to the NANOG list and others and invite people to participate, factor that feedback into how we can make that less bad, right? I guess is the best way to put it. I don't want to say good, right? Because I'm not sure that's really what, what any of our intention would be, but I think it's coming and it's probably coming soon.
Again, not off the hook yet. When you get to full deployment of 6, my guess is you'll be lucky to get to about 50% of your customers actually using 6. And my guess is it's all the Belkins, the Linksys, and all that old CPE out there, which is kind of this boat anchor inside the internet, that folk who buy CPE tend to throw it in a cupboard and forget about it for decades. It's part of our DDoS problem, but it's part of your V6 problem. What are you going to do about all that old CPE? Do you think you can convince the government to buy them? Is this a clunker model for the internet?
Wow, you're hanging a nice softball out there for me, and I almost bet on the government part. So truthfully, it's something I actually worry about, right? And one of the things that we have the fortune of at the moment is the 65% of the customers of ours that have V6, 60% of them are using devices that we provide to our customers, okay? 5% of them are retail devices that support V6. So I worry about it because inevitably you are correct. There's gonna be pockets of these devices out there that are not gonna have anybody to look after them anymore at some point, maybe already now, right? So one of the things that we're doing is we are very interactive with the Consumer Electronics Association. So if anybody has heard of CES, happens every January, big kind of nerd technology, light show in Vegas. We're doing a lot of work with the CEA to really kind of further stimulate. So if you look around the room and if you look around the panel here, a lot of us have done what we could to control our own destiny, right? So I work with my manufacturers and they turn on V6 by default and we put it out there. And that's made a difference, right? But CEA has a much wider net to cast. And we're hoping that, that with some of the work that we're doing with them from a device profile point of view, plug fests, interops and such, that we move that needle. And I think ultimately what ends up kind of solving that problem is putting products on shelves in Best Buy or whatever your local retailer is in Australia and making sure that those things are on by default with V6. So as the refresh cycles pick up, we shrink that population. Fast forward some number of years from now, you'll ask me the same question about some small population. I don't know what the answer is. I mean, maybe the answer is maybe we do it. Maybe we say, hey, here's a router, and then I don't know, right? But our hope for now, the near-term goal, is to stop filling the funnel of things with things that simply don't do V6 by default, right?
So the government isn't going to buy them back yet?
Yeah, no,
Not yet.
highly unlikely.
Paul, I think I just heard something that made my ears just prick up going, that's the first time I have heard someone say, we have the world's most paranoid application. Your application, the Facebook app, is so paranoid, it has an entire network stack in the app. You seem to use the raw IP interface, all that good work by Apple and Android, sort of stuff that, you're doing the lot. What's the goal here? Do you really want to control both ends of the conversation? Is this your way of actually making sure that the user experience in that app is entirely under your control? Because you've got both sides of the TCP. What's the story with your paranoid app?
Hello?
I told you, no warning.
That was like right to the face. It's actually pretty simple. There's multiple devices out there, Android, iOS, Windows, and writing the same network stack for, say, speedy, quick, HTTP, whatever protocols come out in the future. That's really painstaking to implement it on every platform. So we took it upon ourselves to basically write a cross-platform library that we can use on all devices, all operating systems. It's actually the same thing we run internally for our own HTTP libraries as well. So it's write once, use everywhere. And we then decided we would make V6 work properly.
So I'm going to ask you the same question that I asked Gaurav, because I'm kind of interested in this whole issue of Wi-Fi handoff. And if you're in control of your communication, and this device wanders in from cellular radio to Wi-Fi and has both, are you in control of which interface I'm going to use? Is that part of your control mechanisms? Now, maybe I don't use control, maybe it's just a better user experience, but do you see the app controlling the handoff as being one more step in making sure the quality of the user experience is under your control?
Well, unfortunately on that device, they don't give you very much control at all. Usually, but it is actually something that we do because you get notifications as to when the network changes, and we can react much faster in our own network stack than the stock libraries.
Okay, so I've kind of stopped the general grilling, so, breathe easy again. This is a relatively unique gathering of both folk who deploy and folk who produce. And what you're hearing right now is a large number of folks saying, we're well on a V6 path. But it's not dual stack as the goal. It's turning off v4. And that's why, in almost all parts of this industry, when you get a choice, most of the time, you try and give v6 a little bit of a head edge. And what that means is the more 6 gets deployed, the less 4 gets used. And so most browsers, for example, do happy eyeballs. They give v6 a very slight advantage. So each of you in turn, what message would you like to take to Apple and the way that they've implemented their version of a random selection between 4 and 6 on their operating system? Helpful or a problem?
Boo.
Fair enough.
Yeah, I mean, it is not helpful, truthfully, right? So I mean, from our point of view, we're really trying to get, we'd like v6 to have a fair shot, right? You know what I mean? But in many cases it does not. And the funny thing is, Jeff, by asking for that, we also have to kind of eat our dog food when, situationally, right? So we recently had a case where we asked, and we were talking to the Android guys, the folks that we know we're very familiar with, and we said, hey, when's Android going to query DNS over IPv6? So lo and behold, it happens, and we had some issues with our with our DNS infrastructure over v6, and we found out so we had to kind of deal with both ends of that, right? But even with that being said, we still need to see those things happen, right? We like v6 to not be second class, right? We like to have a fair shot, like v4 does today, because that's the only way that we're going to continue to move this needle, right?
Right.
So I think in an ever-growing mobile market, the issues of choosing based on RTT is a very poor model.
But you don't do that in your app, do you?
We don't do it.
So if I run the Facebook app on this thing is made by Apple, all of a sudden it's doing happy eyeballs the way you want it, right?
Exactly.
Cool.
And that's the whole reason why we hope to open source it at some point, so that it's literally a plug and play for most apps, and so that they can take advantage of it. And I don't know exactly what Apple's view is because I can't speak for them, but they are treating it like a second-class citizen, and the data that we shows that it's a first-class citizen.
Great.
So I think NAT 464 is a really streamlined and proven technology, and it increases better user experience. Google and Microsoft is already utilizing that, and they're trying to make sure the user gets benefit out of it, and so does T-Mobile. And using v4 on the network creates more complex environment because you have to maintain the CGN infrastructure that is very expensive and troublesome. So v6 only is the way forward.
Okay, so I've got one more question before I open it up for you guys to ask your favourite question. So this is my last one again to all three of you. I see a whole lot of mixed messages about this wonderful thing called the Internet of Things. The Gartner Group reckons that there'll be 100 billion trillion of them sometime next year or something, I don't know. And it's all going to be worth so much money we'll all retire and be billionaires. And some folks say, it's actually really good to hide them behind NATs because they're so stupid they're actually not allowed out, with real adults. And other folks say, that's nonsense, we just can't build this unless we have 6. So I know particularly with Facebook, it's slightly outside of your core business, but what do you think about the Internet of Things and blowing this away from eyeballs into an entire world of communication? Is 6 a part of this story, or can we do it on 4?
I can't imagine, if the dreams and the wishes of those who have, these trillions of devices in their dancing around their head. I can't even imagine doing it with v4. Interestingly enough, Jeff, we do have some conversations with people in industry about the Internet of Things. It's a very hot topic. It is very, very cliche at the moment. And the problem is it doesn't compute from a scaling point of view, right? A lot of folks, believe that they can use some kind of a border relay or some sort of a box to terminate and translate. I don't see how that is beneficial from a scaling and performance point of view. So for me, v6 simplifies that, right? We've done a lot of work as an industry to kind of make it so that stuff just works, right?
Right.
And then secondarily, I have to also wonder, given the advancements in this space, right, where devices, devices can talk to devices, from a privacy point of view, the one part about the natting thing, or the kind of the centralization thing, is it kind of forces more stuff to be pushed up into a centralized place, right? I have to believe that, again, not only from an efficiency and performance point of view, but also from sheer privacy point of view, there seems to be a lot of benefits to kind of devices being able to communicate with one another, right? So from our perspective, one of the things that we kept in mind as part of our rollout is making sure that we were enablers for as much of these things that are popping up in the community, but also things that we want to put and develop as well, right?
So, Paul, what about your dreams for the FaceBot?
FaceBot?
The FaceBot,
We don't
the
have-
Internet of Things for Facebook.
Yeah.
You heard it here first, folks.
I'll just say this: if we don't get into the home space, but for my own personal opinions, if you are lucky, in the future to have less than 250 some odd devices in your network, because most people have a /24, they're going to be screwed. And getting people to actually sit there and, I need a 23 or a 22 in my house now, you're not going to be able to do that. So the idea is to get the devices to support a large enough address space, or to be able to request prefixes, where you have a large prefix to your house and then sub-delegate internally. That's really the future. Like, you can't really look at it from the standpoint of, let's hide behind a NAT, because anyone with a clue knows that 80% of the botnets out there have RFC 1918 space in them.
So it doesn't work anyway. Yeah. All right.
Yeah, Internet of Things is the next big thing upcoming in the market, and every household, like home automation systems, automobile industry, wearable items like like Apple Watch and all this stuff coming out, Fitbit. It's like exploding right now, and
That reminds me, I've got to go and buy mine this afternoon. Yes.
yeah, it's getting really like in next 2 to 3 years we'll see like it'll scale like anything. So the challenge again, as John and Paul mentioned, is how to assign them IP addresses, how to make them accessible between each other, and how they can talk to your friends. You want to share your data with your friends, and you want to go out to the social sites and say what you're doing. Every house like have an iPad or any kind of tablet or phones and a lot of other things in the house. 4 or 5 devices always active. So the only way you can achieve that scalability is IPv6 deployment. You will not be able to do that with IPv4.
Thank you. We have a few minutes if there are any questions, and I see one on the right.
Randy Bush, IIJ. I don't know much about this V6 stuff, but one of my lives is researcher, so I kind of checked. And of the 1,000 IPv6 talks I've heard, 732 were given by you.
Guilty as charged.
But what I've got is just a couple softballs, which is really from the point of view of a researcher. John, as you watch your usage change with a minimal invasion of customer privacy, it'd be just really cool to watch over time how many smart TVs, which ain't so damn smart about IPv6, actually migrate. How many applications migrate to V6? It'd just be nice to have that longitudinal data just in your back pocket. Write a paper with you sometime.
That sounds great, Randy. I mean, and there are things that we test and measure from our perspective today.
Right.
I think you're spot on, and
But we'll gladly party with you on that. And the telco, by the way, the telco world, as Jeff alluded, is owned by CGNs. So we've got a very rare albino sitting over there. With your customer running naked, I would like to track over time the security incident problem.
I agree, and
I'm not saying it's good, bad, or anything. I'm really just interested in longitudinal data. Pardon me, for those who don't know, sorry, in data collected over time.
yep, I agree, and I personally feel like, we haven't seen much of a DDoS activity on IPv6 as compared to
It's not DDoS.
IPv4
You
or
can
any kind of security incident. So,
Well, you might want to read about the current iPhone vulnerability. But, I was in the elevator coming down and somebody asked somebody what that blue dot was, and he said security. I said the real security people here don't have any dots.
I'm going to take it in circular order, but I think it's okay. I'll cut the mics after Steve because we're going to go a little bit over time, but that's okay. So going around, Alain. Front mic. A bit louder, we should be. Front mic, please.
Here.
Emergency.
Thank you. Alain Durand, ICANN. I have two questions to ask. The first one is a follow-up on what you just said about DDoS. I was sitting this morning into the security panel sessions, and I asked a question, how many DDoS attacks were attributed to V6 versus V4, and the answer was essentially very, very, very few. And if we have about 20% of users in this country that have V6 access, I find that very surprising. So could you first comment on that? And my second question, that would be for John. First off, I would like to congratulate you getting to 40% like your rock. Second, but if you have 40% users, and if I believe the statistics that shows that about 50% of the traffic goes to sites that are V6 capable, things like Netflix, YouTube, and things. Multiply those two numbers, you should get something around 25% of traffic volume being V6, not 10%. So could you please educate me on why this mismatch?
so on, can you hear me?
Mic one.
Can you hear me now? Yeah. So on, I can't disclose because it's more of a T-Mobile internal information on DDoS attacks that we see on a daily basis, but I can tell you this, that on IPv6 side, I work on operations side, so I'm on a daily basis involved in a lot of issues and a lot of things that are going on in our network, but especially on IPv6 side, I can tell you that there is not much activity for DDoS. It's more concentrated towards V4.
So, Alon, to your point, we find that it's, we don't like the answer either. I think what we're finding, the mismatch between penetration and traffic is, it comes into two variables that are still items that we're working on. It's content. Even though the Alexa is now 16% of the Alexa Top 1000, it's still not 100%, right? And we're also finding that from a consumer electronics point of view, many of the devices in a home are simply not enabled for V6 yet. To Randy's point, even if a smart TV were to go V6, the apps on them then also have to go V6. So one of the things that we feel is that work with the consumer electronics ecosystem plus the content side will help to kind of increase that lift and bring the traffic levels up to have more common levels to what we see from a broadband penetration perspective.
Okay, so if I understand correctly, this 40-something% is the number of houses that have a CPE that can do V6, not the number of devices.
Correct, right?
Okay.
65% of Comcast households have been deployed to support IP6. North of 10% traffic, and that will change, from our perspective over time as more and more CE supports V6, and then multiply that by the number of sites they go to, et cetera, right?
Thank you.
Certainly.
Centre at the back there.
Alexander Levin speaking, and the question is, how was your good night's sleep, gentlemen, February to March, due to one particular bug in the Linux kernel connected to IPv6 stack implementation? Have you enjoyed patching this stuff? And how you think, how you can comment on 2 months that it took to get this patch in the kernel? Can you operate on these terms?
I don't. Could you?
The beauty about this industry is that we're all rank amateurs. You might recall the great SNMP bug of 2007. You know, we excel in making code that has rough edges. And to the extent that perfection's a wonderful thing, it doesn't happen very often. I must admit, I do like Facebook going, I'm minimising the amount of externalities here. The app is in total control. Problems in the Linux stack? Who cares?
Well, actually, I think he's talking about our edge Linux servers that are connecting, and we have a top-notch Linux kernel development team, and deploying and patching things are pretty rudimentary for us.
Okay, time is of the essence, so I'm going to keep on moving on. Over there on the right.
Jana Iyengar, Google. I have two questions on this slide to Paul, and perhaps just clarification questions, because that graph is it's actually quite a powerful graph. And I know that in Happy Eyeballs in Firefox and in Chrome, there's a 300 millisecond delay for the v4 connect. Do you have that delay in here, or have you compensated for that delay in here?
So what we've done is, so since we control the HTTP stack, we have a setting that the app will fetch from us that will basically force users to use v4. So we can force a large number of samples to be v4 so that we remove bias, as much bias as we possibly can. And then from there, we'll A/B test against Happy Eyeballs. And 300 milliseconds is way too much on a mobile network. Lorenzo picking 300 milliseconds was kind of a bit much. I think, you know, more people would have Apple probably would have been more likely to implement it the way everyone wanted if it was like 10 milliseconds.
Okay, that actually helps. The second question I had was, you said RTT is not a good enough signal. What other signal would you have with 1 or 2 packets that you could use?
So, I mean, I said that because Apple uses RTT. They issue off 2 requests. My understanding is they issue off 2 requests, and then whichever one comes back first is the one that they use, and then it like does some background calculations or something. Nobody really actually knows what it does. So we see RTT mostly equal, you know, across v4 and v6 on the mobile networks. So we just started to look at total throughput. I mean, it's kind of a data gathering thing. You may have to penalize your users to figure out exactly what's going on. Luckily, there was no penalty for our users. It was actually a better experience for our users.
Right. I think that's where the hard problem is, right? Being able to actually measure throughput requires you to send the request, get a response, and by that time you're already done. But I can take this further offline.
Okay, we have 4 questions left. Think of it as a speed dating night. Make it quick, make it fast, make an impression. Centre front.
So this is for Gaurav from T-Mobile. So something that was left out of your presentation, you know, you mentioned that 464xlat is supported on Android and Windows Mobile. You already know where the question is going. The iPhone does not support 464xlat, and there have been a number of other studies that have shown that iPhone users tend to use more data than Android users. So even if you have half of your total users supporting 464xlat, if the other half are iPhone users and they're using more data, it probably translates to a very large percentage of still v4 traffic. Are you pressing on Apple to do something about this, and do you think they will do something about this?
I think internally there might be discussion about Apple to go with 464 support, but I have no information on when they will do it, so I can't say anything about that.
Up the back.
This is Vincent. I'm from Zendesk, and it's not a proper question, but more like a suggestion. I'm coming from the last RIPE meeting, and during the RIPE 17 in Amsterdam, Jen Linkova and Eric from Google and Cisco, they deployed an IPv6 only network with NAT64 and DNS64. And it was interesting because a lot of people had a first opportunity to test their services coming from an IPv6 only and translation. So I think it's something that might be easy and feasible for upcoming NANOGs. Thank you.
Program committee, take note. Up the front here.
Hi, Steve Feldman, CBS Interactive. This is an old question, heard many times before, but maybe you have new answers for me. We're a content provider. I have V6 in my lab. I have V6 in my office, but don't tell our IT department. The question is, we don't have V6 in production anywhere. What would you say to my management to convince them that we should? That I should actually spend time, that the application developers should spend time working on V6 in our production environment?
So running in your production environment is like the third step I would take in deploying it. One is, I tell people, like, they say, oh, it's going to be really expensive, it's really difficult to do. Really, the first step is to get it to your desktop. The second step is to get it on your edge so that all your HTTP or whatever endpoints can take V6. Whether you plumb that into your network or you pay a content delivery network, get the Quad A records. And then after that, you can start to focus on how to deploy internally and migrate all your infrastructure over, and then you don't have to worry about both things. As far as going to management, you show them that graph. And you say that, look, you're CBS, you want to stream videos to your end users. They're going to get them faster, they're going to enjoy it more, they're going to look at more videos. Hey, we might be able to put in more advertising in our videos because they're watching more. It's kind of a bullshit way to say it, but that's what gets them going. We at Facebook, we're lucky. Our management is forward-thinking, and they let us make the decisions as to what we need to do. Our networking team came to us and said, we're out of RFC 1918. We need to do this V6 thing internally. Our VP of engineering said, go do it and be the best.
Thanks.
The only thing I can say to you is very simple. Very few folk have the capability to actually run their own data anymore. It's such a toxic world, you're forced to push it up into various cloud services. You have no choice. Only those folk have the ability to withstand the amount of toxicity out there. At some point, stupid DNS tricks aren't going to make V4 last much longer. And despite stupid DNS tricks, you're going to find a V6 cloud is going to be cheaper for you as a business. At some point, you're going to have no choice. The economics are going to say move. You're either going to be a victim of those change and react late, or you're going to be proactive and jump early. Up to you and your business and your bottom line.
It's a multiple year effort, and if things continue to accelerate at the rate that they're going, people are going to be scrambling rather than taking their time, figuring out. For us internally, to do V6 inside of our data centers, like V6 only, we could have renumbered. There was actually that talk, but that would have broken our production network. That means we're physically changing things. So when you look at V6 in your internal network, it's just an overlay. You can take your time, you can iterate, and iteration is the best thing that you can do, because you end up not, oh, it broke something, you can roll back. You can test 1% of your traffic, internal requests or whatever, V6. So it's not something that's like an all or nothing thing. If you plan for it, you can succeed without make what we call a career limiting move. So.
And lucky last at the back there. Thank you for being so patient.
Yes, Bill Goldstein, retired from AT&T, but here representing myself and only speaking for myself. The comment from Facebook about corporate America being entrenched in IPv4 is absolutely correct. In my experience, they are absolutely resistant. What was perhaps most disturbing is, even though the federal government embraces V6, just before I left AT&T in March, I saw a proliferation of RFPs from state agencies, which had as a requirement sometimes Class C, even Class B V4 addresses as absolute requirements. The question I have is, what role can Aaron, perhaps playing with the vendors and content in other areas and whose interest it is to migrate to V6, prove as work as a facilitator, particularly for corporate America and for the areas in government outside of federal that should migrate to V6, to help to facilitate that. I know you can't really license or certify products, but even perhaps even keeping a database of available products or services without disclaiming any endorsement might be helpful, because you can hold presentations and gatherings like this, which I absolutely agree with, which are, you know, much more than just well-meaning, but people are stuck for many reasons, and, you know, with the limits of what Aaron can do, can Aaron, working with the organizations who support Aaron, work as more of a facilitator?
So I can actually answer this. I've done a couple of interviews for various tech publications recently, and the reoccurring theme is this Gartner article that states that 7% of your annual IT budget needs to be spent to support IPv6. And as hard as I've tried to steer these reporters away from that, they stick to Gartner like glue, especially the Wall Street Journal. And I keep telling them that it's a load of shit, and it's not really that much. And really, like when I talked about my 3 steps, those are the things to get corporate America. Just get it to the desktop. That doesn't cost you 7% of your IT budget. Most of those large corporations have network gear that supports v6. And so I've been finding that's been the hardest thing to get corporate America go, is because they believe this nonsense that it's this massive cost infrastructure. And in most cases, it's not. At Facebook, we didn't spend any extra money to do v6.
Well, state governments must be reading that same article too, from the feedback I've had only recently. Again, you know, if I realize there are limits in what Aaron can do, and I realize probably Aaron and just what they're doing here is doing perhaps, you know, pushing the limits of its charter. But again, anything that can be done to facilitate this, I think, is necessary, because the resistance out there, and I think for reasons beyond, you know, your the excellent point you made in that Gartner article, it's considerable. I mean, I think it's ridiculous seeing state governments come up with RFPs at this point in time requiring Class Bs or Class Cs of V4. It's absurd.
Thank you. The little red light's now going bong, 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 bong. I want to thank Gaurav. I want to thank Paul, because I've never heard of the Paranoid app before, but this is so cool. And I want to thank John for organising all this. And I'm now confident in the understanding that the government is going to buy my Belkin CPE sooner or later. Thanks a lot. Thank you, everyone.